Hello everybody. Today I will start with the mathematical modeling of the manufacturing process, the first module. But in this module the discussion point is that introduction to manufacturing processes. So, we will discuss at the introductory level that manufacturing processes and that specifically the properties of the material, and which is helpful to analyze the different manufacturing processes. So, the module is arranged in such a way that first some introductory discussion of manufacturing processes, then what are the materials processing technologies, what are the importance, and of course, all these things in introductory level, because material processing technology itself is a very big chapter. And then types and properties of the engineered materials, and which is we can found out the very common properties of the materials, and of course, we will try to look into that different scale, what are the importance of the mechanical properties, and how it influence or how it can decides the mechanical properties, or through manufacturing processes whether there is any change of the mechanical properties or maybe other kind of properties, and how we can evaluate all these properties the different engineering approach, then that will try to get an overall view on that. Then next part of this module will be the physics based modeling approach and at different scale. Mostly I will try to discuss the exactly the approaches from micro scale to the nano scale, or in between the meso scale or grain scale approach we will try to discuss, and in terms of the multi scale modeling approach. But here we will discuss only the approaches, but in details the continuum models and continuum scale models, all these phenomena we will try to discuss in the next module, that what type of equation we can use it to solve any kind of manufacturing problem. Then finally, we will try to look into that evaluation of the properties of the manufactured products, and maybe broadly we will try to discuss the evaluation of the mechanical properties and what kind of testing we can do to check the properties of a material after manufacturing processes. And of course, then last part of this module will be statistical and data driven modeling approach normally follow in case of manufacturing process. They will try to discuss on these things, but all this discussion will be confined to the very overall discussion, or in general sense we will try to discuss all these matters which is I just mentioned in this module. Now, manufacturing processes. So, from what point to start the manufacturing processes? First is the first step is that conversion of the resources into raw materials. That raw materials is a that subject is broadly in mining and metallurgical section. So, we will try to look in broadly that how we can convert the natural resources into the raw materials. So, once the raw materials are available, and then manufacturing processes deals with the from raw materials to form the final product. So, how we can form from raw materials to the final products based on the different type of manufacturing processes, we can get the hierarchy of these processes like that. Say first step of the manufacturing process is the casting process. We know the casting and solidification is one manufacturing process, where casting means we can get a desired shape and specifically size from the molten material. So, we get the raw product maybe in the form of a roll, in the form of a sheet. We normally use in the steel sheet, but that normally forms by the following the casting process, and the first step and the casting process. So, once we get some raw materials in terms of the billets is available, then from that raw materials we can process, we can apply some manufacturing process. For example, if you want to get the desired complex shape, then maybe it is necessary to perform the machining process for this raw material. So, then machining process can be done, or maybe you can get the desired change of the shape, and for example, one sheet metal too we can get one deep drawing process if we follow, and we want to get a particular shape, then we can follow some kind of the metal forming process. So, casting is the first step to get the in the form of a raw materials or stock materials, and from that we can follow different kind of the machining process or forming process to get the these are the manufacturing processes to get the desired product. And of course, not from only machining and forming process, the manufacturing process also associated with some kind of the joining process. If necessary, if we want to join two components, then we can follow some kind of the joining technologies, and that joining of these two components can be in the similar type of the material, or it can be dissimilar type of the materials, and through this joining process. So, once we get the from raw materials to the manufactured components, then it is often necessary to do some kind of the follow some kind of the finishing operation to get some desired surface finish of the particular product. Then we can follow the different kind of the finishing processes. And of course, not only the finishing process, and if you want to get a big product, then may be necessary the assembly of the all the different components, that can also be done, and then after assembly we can get the final product. So, therefore, manufacturing processes actually deals with these three different basic steps. What is the design of a processes, and then production of the processes, and of course, by looking into the production of the processes and gradually development of the new techniques. This is the most of the engineer follow these three basic steps, and of course, these three basic steps we need to understand. So, therefore, understanding of the manufacturing processes in the light of the design, production, and the development of the any new techniques. Once we try to develop the new techniques, then we need to understand what are the already existing manufacturing technologies and what are the pros and cons, advantage, disadvantage of this particular manufacturing techniques. Then only we can propose some kind of the new manufacturing technology. And then of course, once we need to understand all these things, first we look into the design of a manufacturing process, but we design the components of a manufacturing system in such a that it must follow the most economic manner. That means, there are several manufacturing processes available, and maybe we want to get a particular product, and that follow several sequence of the manufacturing processes. So, we need to follow in the most economic manner. In such a way, we try to minimize the cost of this production, at the same time the minimum utilization of the resources, and of course, optimize the manufacturing process in that sense that we need to look into the optimum process parameters we have to choose, such that we can produce a particular product in the most economic way. So, that is the design of the total manufacturing process, or we can say the design of a manufacturing system. Then production, in these cases the production rate of production, looking into the demand, all these things is a part of the manufacturing processes also, and then in that case selection of the important process parameters is the most important here. And of course, in the production at the same time we need to look into the rate of the production also, how quickly we can produce a particular product. That is also important aspect to looking into the overall design of a manufacturing process. So, once we understand the existing process, then or the difficulties with the existing process, and if we analyze all these aspects, then we try to reach maybe some development of the new technologies, and of course, either development new technologies, or we can suggest the modification of the existing technologies. So, that is the most important aspect of any kind of manufacturing engineer. But of course, the production process in certain cases definitely cannot be solved in the conventional. So, some particular development or depending upon the complicacy of the particular product, it is not always possible to develop this product by using the conventional processes. What conventional manufacturing processes? For example, we have already mentioned that this normally casting, machining, forming, welding and finishing, these are the conventional manufacturing processes. So, therefore, sometimes it is not possible to follow or by using the conventional manufacturing process to get a particular product. So, in that cases unconventional manufacturing process are also developed, and of course, this development happens once we get stuck with the existing using the existing conventional processes. So, all this conventional as well as the both non-conventional manufacturing processes, their development, and of course, the approach, the modeling approach, that means by looking into the physical phenomena, that is the basic objective of this course, and we will try to discuss in the discussion in the further modules on all this conventional and manufacturing conventional and non-conventional manufacturing processes. Now, we start with the basic manufacturing processes. We know that these are the typical manufacturing processes, that casting, foundry and molding together. Casting means we simply understand the raw material, we collect the materials and we just melt it and get the desired shape with the help of the foundry shop, and of course, some molding means to hold the molten material, and that for that particular material, if we want to get particular shape. So, then once we pour the molten material in a particular cavity according to our desired shape and size, then after molting, then it is followed by the solidification processes, and then we get some kind of the product. This is in general the casting process that is involved in the manufacturing system or manufacturing process. Then metal forming process means the metal forming process, we never melt the material, rather in metal forming processes we just try to get the desired shape below the operating temperature, below the melting point temperature. And this metal forming processes is one category of the manufacturing process, and of course, the deformation of the metal is the most important aspect in the metal forming process. Then machining or metal removal process, if you want to get a desired shape, complex shapes. So, may be necessary to remove some part of the material to get the particular shape. So, then that kind of to get these things, we just remove the material by following the different kind of the machining processes. This is in general the machining processes, or we can say the material removal process. So, in general it is called the subtractive manufacturing processes, because here it is necessary to remove some part of the material with the help of a kind of another tool material. Then joining and assembly, we simply understand if some product development may be necessary to join the two components, to weld the two components. So, that is the one part of the manufacturing process, we can say. And sometimes we want to improve the properties of the surface. For example, after machining process or any other processes, after welding processes, maybe that particular component may not get the desired mechanical properties. So, in that cases it is necessary to follow some kind of the heat treatment process. So, heat treatment to change alter the properties within the particular structure. It is often necessary after following any kind of conventional manufacturing process to conduct kind of the heat treatment, just to improve the properties, mechanical properties or any surface properties of a particular material. Then surface treatment on finishing operation. So, once we process through any kind of the normally in casting or welding or maybe any kind of the metal forming processes, we may not achieve the desired surface finish what we are expecting in a final product. So, in that cases it is necessary to remove the small amount of the material. So, that is called the finishing process. So, with respect to the machining process, the large amount of the material normally removed, but in case of finishing process very small amount of the materials are removed, but in finishing process the objective is to get to achieve the surface finish to brings the aesthetic part of a particular component. Then non-conventional processes. So, apart from these conventional processes, there are so many non-conventional processes has been developed when we face the difficulties by applying of a particular application of a particular size, shape or particular material. When we follow you want to not possible to apply the conventional processes. So, in that cases non-conventional manufacturing process has been developed. We will discuss the different non-conventional processes also. And then finally, the additive manufacturing processes. So, additive manufacturing processes is completely different from subtractive manufacturing processes, that means with respect to the machining process. So, additive manufacturing processes here we can develop the product by layer deposition process. So, in these cases as opposed to the machining process, the loss of the material during the process is very less in case of the additive manufacturing process. So, in additive manufacturing process normally we can produce a particular product by fusing the powder or by sintering the powder, and we want to get the desired shape, and of course, we achieve the desired shape not a single layer. So, with a small layer deposited, and after that the deposition of the next layer. So, that layer by layer deposition is the main strategy in case of additive manufacturing process. So, all these manufacturing process we will try to look into in details and their modeling approaches in the different types of the modules. Now, materials processing technology. So, material processing, what we understand the manufacturing of the raw materials into the finished good, that is in general called the material processing. But industrial process, how we collect what we can from the raw materials, for example, in terms of the steel bar, for example, what we can do these things, but that various we need when we try to produce the some raw materials, then various mechanical or chemical procedures you need to follow and produce the large quantities or batches. That means, by following the mechanical or chemical procedures from the ore material and to extract the raw materials, and that normally done as a large quantity in terms of the batch. And raw materials is actually extracted from the minerals or produced from the basic chemicals or can be from natural substances, that is called the raw materials. For example, the metallic raw materials and crude ore is processed to increase the concentration of the desired metal, and it involves that crushing. For example, what we can collect from the nature, that crude ore, and that ore is not directly, you cannot use the ore for the manufacturing process. So, what happens in the ore, first we crush and then roasting, and sometimes if magnetic separation can be followed, flotation means a lighter, we can separate out the lighter and heavier components, and all these processes following these things we get the materials, and that is normally smelting and we follow the casting process normally in these cases. So, thus once we collect the raw materials after metallic raw materials from the crude ore, that means we just convert the crude ore to the metallic raw materials, and then raw materials are smelting, basically melting, and then it is necessary some alloying. That means we can produce, we can make it and in the form of the alloy by adding some other components, and finally we produce the metal or metallic alloy that is basically fabricated into the final components through the some manufacturing processes, and we can get the desired product, or directly we can eventually assemble to the desired products by following some kind of the manufacturing processes. Now, material processing, and we can take one example. For example, the iron, iron normally found as mineral compound such as ores, and then basically iron ores is a mixture of the iron oxides and some impurities. So, first step we try to improve, we try to remove the impurities from the iron oxide, then we try to the iron oxide, then we try to reduce the oxides. So, therefore, chemical reducing reaction should happen to extract the actually in the form almost pure iron from the iron ores. But how you can extract? So, once we remove the impurities from the iron ore, the iron oxides are along with the limestone, coke, air, all are brings together, and they are actually melt in the furnace and reacted in the furnace by application of the heat energy. Now, these oxides are removed because we add the other component limestone, coke and air, that actually helps to remove the oxides and finally to bring the almost pure iron. But sometimes oxide reduce, that is fine, but at the same time other elements are also mixed with the iron such that we can produce the some kind of the wrought iron, or which is called pig iron. So, we can see that different components actually mixed. Carbon normally 3 to 4.5% is mixed with the iron ore. Manganese can also be mixed, phosphorus is mixed, silicon certain percentage, and sulfur all are mixed, and then we produce some kind of raw materials which is called the pig iron. So, once pig iron is cast, then once the pig iron is cast at the desired shape, which is called the cast iron, and other impurities actually in the pig iron is forms into the shape through the casting process, and that is called the cast iron. And of course, other impurities are forms in the form of the slag, and that we just simply remove the slag. Steel can also be made, but steel can also be made by the further oxidation process, and that decreases the amount of the carbon. So, normally the cast iron carbon percentage is more, and then if we reduce the further carbon percentage from the iron ore, then we can produce the steel, and of course, this steel is processed through further oxidation and just to reduce the amount of the carbon, and of course, Mn, sulfur, phosphorus is normally removed from the cast iron, or maybe you can remove from the pig iron, and then steel can be form. Of course, in this process, so during the removal of this different components, carbon, manganese and phosphorus and sulfur, and then at the same time the steel scrap also can also be added, and finally we can make into the desired shape the steel product. And of course, it is in general this is done normally following the casting processes. So, from the iron ore or from the raw material iron ore, we can produce the both cast iron, and then or in the sense you can say the pig iron, or we can produce the steel, and that then steel is basically we can utilize the steel and the through following the different manufacturing process and to produce the different type of the products. So, once the material processing the iron ore to the either steel and cast iron, then the start of the manufacturing process with respect to that, how we can process this material steel or cast iron to convert into the desired product. And of course, this conversion from steel to final desired product, intermediate components are the different manufacturing processes. Now, with the introduction of the different manufacturing processes, now we will try to look into the properties of the engineered materials, or what types of the engineering materials normally used for the human being and for the development of the our society. So, what are the different type of engineering materials? Normally is the 4 basic category we can see that. First is the metals and metallic materials, we can see first. Second was the ceramics and the glasses is the another category, composites is the another category, and polymer. These are the 4 basic category of the materials, and of course, there are certain specific type of materials also available. But metals and metallic materials, we understand the it is a good conductor normally, the electricity and the heat normally, and but susceptible to the corrosion is the involved in the basically the iron steel product or iron product, and then strong, very strong, but it can be deformed. That is the typical characteristics of the metallic materials. Ceramics and glasses is normally opposite to that, thermally and electrically non-conductive, or maybe thermally and insulating almost. So, it acts as an insulator, and of course, at the same time there is very high temperature, and of course, these ceramics and glasses normally can be used in the fast environments, but it is very hard same time, but ductility is very low, that means it is very brittle material. These are the typical characteristic which is completely different from the metallic materials. Now, composites is is as simple as that, making the consist of the more than one type of the material is mixing, we can make the material such that the combination of the properties, it retain the combination of the properties of the both the components when we make the composite materials. Then we can use the polymers, and polymers are the very large molecules, we can typical characteristics of that, and it is a low density, low weight is very low, and of course, this is very much flexible, we can get the desired shape or shape and size so easily as compared to the metallic material. Now, ceramics, we can get some example that it is a combination of the metals, non-metals. So, aluminum oxides is the pure aluminum is the metallic material, but aluminum oxide is the ceramics. Silicon carbide, silicon dioxide, all are the kind of ceramic materials. Basically, oxide, nitrides and carbides normally are the ceramic materials. The application, the bricks, formation of the bricks, tiles, refractories, so there you can find the application of the ceramics. Polymer, plastic and the rubber material, and of course, the organic mainly consists of the carbon and hydrogen, the main component, and of course, other non-metallic materials also involved to make the polymer is the component. So, example is the plastic and the rubber materials. Composites, we can say the concrete, we can consider concrete as a composite material. Plywood, fiberglass and plywood also a composite material. This plywood can be formed the mixing of the different fibers from the wood, and we mix it, it can be continuous or it can be discontinuous. So, all this type of engineering materials normally use in the daily life, but engineer need to understand the properties of this engineering material and structure and properties of the engineering materials, because the pillar of the manufacturing process analysis is based on the 4 steps. First one step is the structure, property, how we can process and perform. First, if you want to understand the performance of a particular engineering component, then we need some relation or need to know what is the structure of the property. So, we can start with the structure, what is the specific structure of a particular material, and then if the property depends on the structure of the materials, of course, and then once we know the particular property, then we need to think about, if this is the particular property, what are the manufacturing processing technologies we can apply for this particular type of the material. So, all are related actually, and then once we know the manufacturing processing, after following the manufacturing processing we can make the product, and the fourth step, once we make the product, then we try to analyze what are the performance of this product. So, this link performance with the processing with the property, and property with the structure is very much needed for a particular mechanical engineer. So, structure, that when you analyze the structure of a particular component or particular material, and then there are several scales to understand the structure of a particular material. For example, the subatomic scale, the atomic structure, what is the atomic structure, and then atomic scale, then microscopic scale, microscopic grain scale, and the microscopic scale means you can see the structure and properties, we observe the properties of a particular material when you try to look into through the microscope. Then microscopic scale, what are the properties, and then macroscopic properties. So, macroscopic properties means if we simply do the tensile testing of a specimen, what is the tensile strength, yield strength, ultimate tensile fracture strength of a particular material, that is the, we can say that is the macroscopic property, but this macroscopic property depends on the microscopic scale, what is the understanding of the microscopic behavior, and then microscopic behavior also depends on the atomic. So, there are several ways, different scale we can analyze the properties, and all are related, and but once we understand what are the properties in the macroscopic scale, then we need to link with the through the multi-scale approach of the properties at the different scales. So, that property of a material, we understand that there are different types of the properties, mechanical properties, electrical, thermal, magnetic, optical properties. Depending upon all these properties, then we can analyze what type of manufacturing processes we can apply for a particular material, if we know all this, if we know their properties also. So, therefore, based on these properties, the different manufacturing technologies has been developed. Advanced materials, the properties is like that: magnetic information storage, that is the for advanced kind of material, liquid crystal display, LCD, what are the particular property, and the fiber optics, all this kind of application we can these properties are important in case of the modern application for a kind of advanced materials. Then the material semiconductor, we can see that silicon germanium based tantalum oxide used for the ceramic capacitor, they used, but properties of the semiconductor is in between the conductors and insulator. And of course, the electrical, but most important in semiconductor is that electrical properties can be very precisely controlled, that is the main purpose of using the semiconductor device. Biomaterials, we can see the different types of the biomaterials, different types of the materials, for example, bones and teeth, artificial bones and teeth can be made from hydroxyapatite, that is one type of the ceramic, and then artificial organ can be made from the plastic, and bone replacement can be from the titanium alloy. Of course, that is implanted in the titanium alloy, can also be implanted component in human body. So, all these engineering materials basically when you use some as a biomaterial, so that should be there you must follow some kind of biocompatibility, that kind of property is needed, for not all materials fit for the biomaterials. Then smart material also available, we can use the smart materials for example, in case of kind of sensor actuator, the smart material can be used. So, there the basic properties of the smart material, we can look into that, how this material behaves, change with respect to temperature or with respect to stress or with respect to humidity or chemical environment in case of smart material. Then example is the safe memory alloy, piezoelectric ceramics, magnetorheological fluid. So, safe memory alloy is a sense, it has very small change in temperature which it changes the behavior. So, that kind of the normal material, for example steel or iron, that may not behave that kind of safe memory effect in the normal temperature or maybe very small change in the temperature. So, that is the specific properties of the material, and that is that type of materials is we normally use in daily life. Piezoelectric magnetoroidal fluid also, that fluid properties is influenced by the magnetic field. And of course, apart from that, some certain materials are also developed in that is called the nano engineered materials. That means by introducing the nanoparticle, by mixing with the properties of the nanoparticles with the materials, their nano engineered materials are also been developed. So, that is for the high technology application or maybe very specific application, or if you want to achieve very specific properties, maybe nano engineered materials is most applicable there. But apart from all this development in the properties of the materials, and of course, and these properties, all these materials are important for a manufacturing engineer, because if we know the properties of the material, then it will be easy to decide the what type of manufacturing process can be followed or can be used in a particular component or particular product. But modern materials need looking for the application in that kind of areas. For example, high performance engine, nuclear waste processing, hypersonic flight making, that communication industry, construction industry, the people are looking for application of this particular area and so for a particular material, or in the from the materials point of view, development of the materials is needed to fulfill this kind of demand in this particular area. Now, we will try to look into that different metals and alloy, that means in overall idea or overall knowledge about the different types of the metals and alloy normally used in the engineering application. So, metals and alloy, normally we can see the metals, definition of the metals is I think not necessary at this level. It is a very hard, shiny, malleable, ductile, these are the typical properties along with the good electrical and thermal conductivity normally happens in some of the metals. We know that iron, gold, silver, aluminum and their alloy are under these categories of metal alloys, and all are having different kind of the properties. For example, normally silver, gold having very high thermal conductivity, but iron and maybe iron alloy having the less thermal conductivity. So, there is a different metallic alloy having the different kind of the properties. Then if we categorize the different metals and alloy, we can see these are the engineering materials normally available. First is that metals and alloy, we can categorize that ferrous metal, two categories. First is the metals and alloy, that in general ferrous metals and non-ferrous metals. So, in ferrous metals normally these steels, and we can categorize the steels and cast irons, and steels, among the steels there are plain carbon steel or alloy steel, and among the cast iron these are the white cast iron, malleable cast iron, grey cast iron. These are the typical categorization of the different metals and non-ferrous metals. Non-ferrous metals we can use the engineering mostly copper alloy, nickel alloy, aluminum alloy, titanium and titanium alloy, of course super alloy and maybe some other alloying elements we can use mostly, but this is the mostly used engineering or most commonly used the engineering materials which is under the category of the non-ferrous. So, difference between the ferrous and non-ferrous, in ferrous metals the main components is the iron, and non-ferrous metals the iron is not the main components, then it depends on the other components. So, that based on that different types of the non-ferrous metals has been developed. Now, this plain carbon steel, maybe in the components of the plain carbon steel as simple iron plus carbon, but apart from that small amount of the phosphorus, sulfur, magnesium, manganese and silicon. So, these are the typical components of the plain carbon steel, but we can see, we try to look into the overall, look into that plain carbon steel can be different, three different. Low carbon steel is based on the carbon percentage, low carbon steel carbon is less than 0.3%, and of course, the structure of the low carbon steel are usually ferrite and pearlite, a mixture of the ferrite and pearlite in general sense I am talking about, Medium carbon steel, the range of the carbon percent is around 0.3 to 0.8% carbon, and of course, the structure is may form the bainite or martensitic structure, but there may also exist ferrite and pearlite structure as well also. Medium carbon, high carbon steel normally greater than 0.8% of carbon, and it can form the martensitic structure also. So, these are the 3 different category of the plain carbon steel, but in general the strength actually increases with increasing the carbon content, and of course, not only the carbon content, how the what is the form of the carbon existing with the particular material and how it distributed, the strength depends on that, but in general it increases with carbon content. At the same time, when the strength increases, the ductility and the toughness actually decreases, or we can say the ductility and toughness decreases with increasing the carbon content. This is the general conclusion of the plain carbon steel. Now, alloy steel apart from the not only the carbon is the not only alloying elements, but in the apart from carbon there are other alloying elements with a small quantity normally added to improve or to get some certain type of the properties. Normally the strength and hardenability, and sometimes not only the strength, the hardenability, sometimes to impart particular, for example, if you want to impart the corrosion resistance, improve the corrosion resistance of a particular steel, then we can add certain alloying elements relatively much quantity up to 20% to purpose the special properties, for example, corrosion resistance. So, that means to impart the certain particular properties, we can add a particular alloying element. So, this is the, of course, there is differential influence of the alloying elements, I am not going into that direction, but in general the alloying elements in steel are this, all these components can be added to impart the, to add particular properties or different properties we can introduce by using the alloying elements, but of course, all alloying elements having the different influence on that. In general, the alloy steel, the high strength low alloy steel has been developed. It is normally application, we can very structural application, bridge and building, there we can found out this application of the HSL steel. Then microalloy steel, it is normally acts as a substitute for the heat treated steel. Then merging steel, super high strength and toughness depending upon the what are the different kind of the phases exist and distribution of these phases and particular morphology it creates, and based on that it achieves the very high super strength and toughness, the merging steel. Stainless steel, also we know the stainless steel is mainly used for corrosion resistance, and of course, the chromium content is very high normally in stainless steel, that actually imparts the kind of corrosion resistant properties in stainless steel, that is the main properties of the stainless steel. Then tool steel, the particular tool steel has been developed looking into the wear resistance, toughness and the high strength. Basically, the tool steel is designed in such a way that even at elevated temperature it can retain its hardness. So, that is why tool steel has been developed. Then silicon steel has been developed looking into the electric and magnetic application. So, where the electric and magnetic application is the requirement, there you can utilize the silicon steel. So, basically by looking into the different requirement and different areas, we can there is a gradually development of the different types of the steels, and accordingly it is apply, and these all are in the under the category of the alloy steel. Now, we try to look into the cast iron also. Cast iron normally categorized as the when the iron along with the more than 2% of the carbon. If we look into the iron carbon equilibrium diagram or phase diagram, we can see that more than 2% carbon is added with the iron, that is under the category of the cast iron, and less than 2% it is under category of the steel. So, apart from the carbon percentage in cast iron, there is molybdenum nickel can also be added to improve the hardenability, and of course, but the properties depends on the what way the carbon exists within the cast iron. That means either carbon exists in the form of the graphite or carbon exists in the form of the cementite. Cementite means iron carbide. So, properties depends on that. So, cast iron we have seen the category of the cast iron is grey cast iron, white cast iron, malleable cast iron, normally these 3 category, and grey cast iron normally in general the cast iron is little bit brittle as compared to the steel, but as compared to that grey cast iron having the low ductility is little less, but grey cast iron having excellent compressive strength, good machinability properties, wear resistant properties, and most important thing is that sound and damping characteristic capabilities are very good in case of the grey cast iron, but because in carbon exists in the grey cast iron in the form of the graphite flakes, and that graphite flakes actually act as absorbers of the kind of the vibrating load. So, having that is why grey cast iron having very good damping properties. Of course, in case of machinability, the graphite act as a lubricant also. So, in ease of machining, it basically makes the ease of machining. So, that is why grey cast iron having this kind of properties because of the carbon exists in the form of the graphite flakes. Then white cast iron, but in white cast iron carbon form in the exist in the form of the carbide. So, Fe3C is actually very hard. So, that is why white cast iron is very hard as well as the very brittle material. Therefore, application where the abrasion resistance is the more requirement, in that cases we can apply the white cast iron. Malleable cast iron, it is a malleable cast iron actually normally produced by through the heat treatment controlled way from the white cast iron. So, in such that the cementite Fe3C or carbide cementite is basically decomposed, dissolves and try to form the regular graphite ferroids. So, that graphites in almost spherical shape actually converts from the iron carbide. So, through the heat treatment process. So, therefore, once a graphite ferroids exists within the structure, we can expect the good ductility as compared to the even greater ductility even as compared to the grey cast iron. So, these are the three different types of the cast iron normally we use. Metal, in summary, metal and alloy, we can see that ferrous metals we understand that it is a iron as the main component, non-ferrous other than iron as the main constitute for the non-ferrous metals and alloys. Steels we can categorize as the less than 2% carbon, cast iron carbon percentage is more than 2%, and then there are different non-ferrous alloy also, for example, copper. There are several applications and several types of the alloy elements as possible using the copper and along with the other alloying elements, but pure copper is normally restricted to the application of the electrical industry because thermal conductivity is very good in case of the copper. Aluminum alloy, most now the development of the aluminum alloy is, although aluminum is pure aluminum is very soft, but aluminum alloy the development of the aluminum alloy has in such a way that even that can be used for the engine component also, automobile engine components can be used. So, therefore, apart from that automotive frame, the aluminum, the application of the aluminum alloy we can found out. Nickel alloy having the outstanding strength and corrosion resistance properties. So, we can find out the application of the nickel alloy, there are several nickel based alloy. Then titanium alloy, normally we use the high temperature engineering application, and therefore, titanium is mostly used for the aerospace. Also, we can find out the application of the titanium alloy because of these properties, high temperature material. So, therefore, all these properties retain even at high temperature. Then apart from this, there are super alloys also developed, and that super alloy they achieve very good high properties kind of combination, the high strength, creep resistance properties. We will discuss the creep resistance, oxidation and corrosion resistance properties also, fatigue resistance even at very high temperature. So, therefore, to get that requirement of particular properties for a particular application, then super alloy we can find out the application of jet engine, rocket engine, nuclear application, and of course, super alloy can be formed in this way also, nickel based super alloy. One example is the Inconel HAST alloy, these are the example of the nickel based super alloy. Then of course, super alloy can be formed iron based and super alloy can be formed also cobalt based. So, these are the overall view of the different types of the metals and alloy and normally use and engineering application. Now, we try to look into the polymer. So, polymer material is actually made up of many repeating the Mars units basically. So, one example, so suppose this is one polymeric material, this is the one unit which is called MER. So, repetition of the unit to form a long chain kind of things. So, that this is typical structure, but polymers are mostly organic substances and containing the carbon and oxygen, mainly a carbon, oxygen and hydrogen, and of course, some structure having the silicon, chlorine and sulfur also. So, here you can see the one example is the polymer structure is the PVC, polyvinyl chloride. So, this substructure is hydrogen making the bonding with the carbon, and apart from that there is a one chlorine also atom also there. This is the typical, but this represents the one is the N means is, so here the one it indicates 1 mar unit mar. So, now this mar is added to make a long chain, and this is the typical structure of the polymer. The properties of the polymer is in the low density, corrosion resistance, design. So, we can design we can impart the different types of, we can impart some color and all these things. So, we can versatility in the design can be followed in case of polymeric material, but normally if you mix the organic organic substances carbon and hydrogen in this form CnH2n+2, and that normally you can find out the polymeric material in this form, the covalent bond, the bonding between the carbon and hydrogen. But this is the normal structure of the polymer, but this can be look into the two parts, one is the thermosetting, one is the thermoplastic polymer. So, then thermosetting and thermoplastic polymer is based on that how it responds at the temperature, based on that we can get the, we can classify these two parts. We can look thermosetting is basically at elevated temperature the materials it becomes softer, and then when it is cool then we get the desired shape and it becomes more harder and stronger. So, therefore, this process involves no change in the chemical composition, and thermosetting polymer is significantly stronger, it is more stronger, more rigid as compared to the thermoplastic. So, therefore, thermosetting polymer means, thermosetting means it is set with the desired shape with the application of the temperature, but other way thermoplastic polymer is basically soft over a range of the temperature, we can process even for the injection molding, and in these cases large amount of the permanent deformation is possible, and of course, it is having useful strength, but strength is less than as compared to the thermosetting polymer. In general, thermoplastic basically heat forming, we can say the thermoplastic is the heat forming, that we get the desired form shape by heating, and then thermoset is basically heat setting, heat forming, and thermosetting is basically heat, by application of the heat we can set the particular shape and size. Then thermoplastic is the bonds normally are covalent bond, but thermosetting like basically both bonds are covalent as well as the cross link bond are there. So, since existence of the cross link bond is makes it more harder or more stronger as compared to the thermoplastic material. So, this is the overall structure of this thermosetting plastic and thermoplastic. Now, elastomers. Elastomers is the basically we can say the elastomer is a kind of polymer, is you can elastic polymer, we can say it is called the elastic polymer, and it is a kind of special class of the linear polymer that display the large amount of the elastic deformation. It is associated with large amount of the elastic deformation and acquire cross linked structure. So, in elastomer it can achieve the cross link structure also. Example of this elastomers is the natural rubber, is the oldest elastomer. Then polyurethanes, then that used in the textile industry and making some kind of manufacture of elastic clothing. Then polybutadiene used in the tires of vehicles, this kind of elastomer you can use. Neoprene and the wire insulation, basically normally wire insulation, insulating belts, we normally find the application of the neoprene, and the silicone is the medical prosthesis. So, all these cases we can use, these are the typical application of the different types of the elastomers. Composites consist of the two or more physically distinct material, but with at least one of the material providing the reinforcing properties. So, then natural composites we can say the bone, wood, bamboo, these are the natural composites, and there we can see if we even for the wood also we can find out the fiber also, even bamboo we can find out the fiber also, that fiber brings the reinforcing properties to the composite material. Engineering composites we can create the glass fibers, carbon fibers, synthetic fibers, metal fibers, ceramic fibers that impart, these fibers actually impart the strength of the component, but this fiber can exist in the form of the continuous way or maybe in the form of the discontinuous way. The properties of the composites maybe depends on the what are the two or more components has been used. So, it can we can expect some intermediate properties when we mixing the two components in to form a kind of composite materials. So, these are the three basic, the laminar, are partically reinforced, or we can say the fiber reinforced composites. Another kind of the material, that is the ceramics and the glasses. So, ceramics and the glass is the complex compounds of the solution that contain both the metallic and non-metallic. We can already discuss the ceramics having both metallic and non-metallic components, and non-metallic, that is carbon, nitrogen, basically carbides, nitrides, oxides, that and the phosphorus and sulfur. These are the apart from the non-metallic components you can add. Typically ceramics is very brittle and hard, and but of course it exhibits a very high strength, high melting point, low, but characterized by the low thermal conductivity and low electrical conductivity, but good chemical and the thermal stability. So, of course, at the creep resistance is very high, and these ceramics can be used at high temperature application also, and can be made from the amorphous structure, which is not a regular crystal structure you can found out, but rather we can the amorphous structure with a random pattern like glass. We can, this kind of structure you can observe in case of the ceramics also. That is why glass, maybe glass and ceramics is normally under the same category. Application: pottery, brick, making the brick, tiles, glass, magnets. There also you can find out cutting tools, refractories. Here you can find out the lots of application of the ceramics materials. And what are the types? Say aluminum oxide, we can say it is a ceramic material. Magnesium oxide, silicon oxides, nitride. There have been basically oxides and nitrides of the different metals. They comes under the category. They are called the ceramic materials. And then semiconductor is the one type of the interesting properties of the one type of the materials. So, semiconductors is basically conduct electricity between the metals and non-metals, between the metals and insulator. So, some intermediate way, but in semiconductor most important the what way the electrical conductivity can be controlled, that is the most important part in the semiconductor. So, if you look in the periodic table, you can see silicon, germanium and tin is the periodic table serve as the boundary between the metals and non-metals. So, therefore, silicon and the germanium can be used widely used as a semiconductor materials, but oxygen, tellurium, Te, zinc to mercury are more, can be used with the silicon and germanium to form a semiconductor. So, these are the impart to the to control the electrical conductivity to the semiconductor by adding this type of materials, and that we choose from the analysis of the periodic table. For example, gallium arsenide, which is one type of the uses the high temperature rectifier and a laser material also. So, to induce the laser radiation. So, that is a one type of the semiconductor material. Then cadmium sulfide, also low cost solar cell we can use, we can find the application of the semiconductor, and that particularly used for the conversion of the solar energy into the electrical energy. So, cadmium sulfide one type of the semiconductor material. So, of course, apart from that some ceramic also display the semiconductive behavior. For example, zinc oxide, and which also behave kind of semiconductive device, but mostly used in case of the color television.